Hi, I'm Lauren. I'm a senior studying mechanical engineering.
Hi, my name is Noah. I am currently a senior here at Roger Williams as well, and I am studying international relations and foreign language.
And you have no knowledge of the ocean, right?
I know a few things.
What are the things?
A few things.
Okay. Alright, so today I'm going to be teaching you about wave energy converters. Do you know what that means?
My guess is that it is an energy source that is using the energy fueled by waves to convert it into electricity.
That's pretty good. That's probably what I'm going to be explaining. Okay, so first, waves. Do you know how waves are created in the ocean?
Waves are created in the ocean by the wind.
Okay, you're smart. Yeah, so they're created by the wind, and wind is created by the uneven heating from the sun. Alright, so first, we're going to look at the surface of the water. So these are little floats, and each of these floats just sit on the surface of the water and they move with the waves, so they move up and down. And they have these cables that they move up and down. And the cables move these magnets up and down as the waves go up and down. So this one's going up, that one's going down. Get that? Like, yeah. And they're anchored to the bottom of the seafloor here. So they're not moving anywhere. And they're just doing that, and they're generating electricity. And that electricity goes to the shore through the cable.
Amazing!
Do you have any questions about it?
So it almost acts kind of as a pump, as it goes up and down.
Yeah, it moves up and down, and there's the
electricity.
magnets, it creates electricity, and that is transferred into the cables, into the shore.
How far off the coast are these typically located?
Don't ask me questions I don't know the answer to.
Well, it can't be too far.
I'm sure it could be pretty far.
How long are these cables?
I don't know that exactly, but I'm sure they could be pretty long because electricity, it's just going to keep moving through the cable. It's not going to stop. I'm not an electrical engineer.
What are these
So-
cables made out of?
I'm not an electrical engineer.
You don't even know the metal composition?
I'm
The
not an
copper,
electrical engineer.
aluminum?
There could be copper, there could be aluminum, there could be steel. I don't know. Probably not steel. Are you worried about marine life?
No, it's just I understand that the copper industry, copper is a lot of money, and aluminum is also a very good conductor, and it is cheaper. You definitely got to have aluminum or copper, something that's not gonna rust as well as obviously not gonna be doing steel as a conductor.
I'm not teaching about the wires though, about the wave energy.
You can sell copper for $2 or $3 a pound nowadays. Post COVID, it's
Okay. So, like I said, are you worried about the marine life? Like, what if whales swim and they come into this?
I'm not worried one bit.
Oh, well, the engineers were worried about that, and so they put an acoustic avoidance system in there, so it sends out sound waves to keep animals away. So, because if a whale came crashing into that, it would not only injure the whale, but it would probably damage the wave energy
How
converter.
fast can a whale move that it would get hurt by this?
I'm sure they can move pretty fast.
How many nautical miles per
I don't know.
hour? I mean, I understand that thing getting hurt, but a whale getting
I
hurt?
mean,
It'll
if
be fine.
you're driving your car and you hit
They're
a deer,
they're a good source of oil.
no.
I mean, they gotta be able
if
to.
you're driving a car and you hit a deer, the deer's gonna get more hurt than your car. No, your car's gonna get more hurt.
Well, that's
the deer's
because
gonna get hurt.
a deer is moving and the car is moving, so it kind of. But like if that thing's not moving, it's just like this, and then the whale. You're like, how when cars go at each other, if they're both going 40 miles an hour and they collide,
I think
it's
we're
actually
getting
like
off
an
topic
80 mile an hour.
We're getting a little off
Listen.
topic.
I'm
So,
just saying.
do you have a good understanding of what wave energy converters are now?
Yeah, I think so. I'd say so. Yeah.
All right.
My name is Adam Kiskin, and this is my dad.
Zeki Keskin.
He's an aerospace engineer for how many years now?
Over than 20 years. So yeah, I am a very, very experienced engineer.
Yeah. Do you know what we're talking about today here?
Actually, not very well.
So the reason we are having this conversation is I want to talk about wave energy. Have you heard of wave energy before? Do you know what it is?
It is very, it is very seldom. Maybe I heard something, but I don't know this mechanism or its process. So,
Yeah.
So you can say I don't know anything about it.
Okay, so it's a renewable energy source, just like wind energy. Do you know? I'm sure you know about wind energy and solar energy. So wind energy, wave energy is like very similar to wind energy, where it's like collected. Pretty much the same idea, like through motions, like we convert energy, like motion, to electricity or other energy sources, whatever. The biggest difference between the wind energy and wave energy is that wind energy is like less predictable because we don't know in the future how the wind is going to act. Like next 20 days, 30 days, we don't know how wind is going to be, if it's going to be powerful, like strong or not. But with waves, we can predict more.
So my first question is about that. For example, why the wind energy we use it, maybe we started to use it maybe 20 years ago, 30 years ago.
Yeah.
So why so far why we, the wave energy did not become a useful tool or application?
Source.
Yeah.
Well, that's a great question because that's what I'm going to talk about now.
Oh, nice.
So one of the biggest reasons is the efficiency is low for its cost. So as you know, wind energy for wind turbines, we can put them out in the like offshore, onshore. Like we can have these turbines like on land where like maintenance is like easy to like go up there like and fix the things if something is broken. But with wave energy, these like designs have to be out in the water, like far away, and so like maintenance costs a lot. And plus, like one of the biggest costs is like the design itself, because it's out on the water and the waves are like very destructive. In order to keep this like design like working for like years, we have to use a lot of material, like metals, like it's like really heavy metals that we need to use, and like a lot of like it's a very big design which we have to put a lot of money into to make sure it's working. And because it's like they're so heavy, the efficiency is so low. The efficiency is about like 30%, which is like pretty low compared to wind energy. However, one of the biggest things like in the future right now where we're like there's a lot of research going on wave energy is because potentially wave energy can like produce more energy than wind. Like I said, winds are not predictable, waves are. So we are like, if we can design these like I don't know, tools like out in the water, like energy collectors, like less heavy and like less cost effective, I guess, more cost effective, potentially we can produce more energy through them compared to wind. So that's one of the biggest reasons why we haven't like gone into wave energy as much as wind energy right now. But
so my other question is, how is, as you are a mechanical engineer,
yes,
how it is related to you, for example, in this kind of the projects. As a mechanical engineer, what area of related with you of that project?
I would say definitely the design, because these are really hard like designs to come up with. First of all, it should be able to collect energy, but it should be also heavy for it not to be like get destroyed by the waves. And so like I'm pretty sure, like I haven't done any of this research, obviously, like I haven't been part of this wave energy like collectors, but I would only assume that like SolidWorks is like big part of it, where you design a lot of like these, like have these designs and test them. And recently actually there's like this new design that came out by a researcher on this topic, that somehow they came up with this design where it's like about 50% less material used, so like the weight of it is like cut by 50%, as well as the cost. But also it's more efficient because they created some kind of mechanisms inside of these, in this design, where it collects more energy because there's more movement with the like whatever they did on the design. So I can only imagine as a mechanical engineer, like I would have to design that collector that's going to go out in the water.
Biggest part of it.
That's the biggest part of it, I would think, at least. Yeah, because efficiency is like the big problem right now.
So my other question is about, let's say, in your opinion, how long does it take we use that kind of systems in our daily life?
It's hard to say. I would definitely assume within like a couple decades, because
Couple decades.
yeah, because like the design that I just mentioned actually like was a big step in the future. So I can only imagine from here we can like design more like better tools, better collectors that we can put out in the water within like a decade or two. I only imagine.
So could you speed up that process, because I am 52 now. So I want to see also the results
I'll
of
make sure. I'll make
that
sure.
studies and
Yeah,
Okay.
I'll make sure those engineers work hard on these and
Okay,
get them
so
done.
as an engineer, I'll be happy to see that as well.
Yes. This design recently that came out also, not recently, sorry, a couple of years ago, I believe, that in one of the European countries came up with this idea where the design is like a V-shaped and there's a bunch of rotors on that like shape where like it can increase and decrease the angle to collect more energy. And it's very interesting because something like that can help us a lot to increase the efficiency and like get less, I don't know, don't get destroyed by the waves. So hopefully
it works.
Yeah, there's a lot like there are devices out there right now working. Like it's not like it's just like on theory so far. It's more like we already have things out, like collectors out on the ocean doing its thing, but it's not as common as wind energy.
Okay, so good news. Thank you for that. Good news also.
No problem. Well, hopefully, if I speed up the
the
process with those engineers, we'll get in within a couple years.
Especially the Roger Williams University.
Yeah.
engineers. I trust them, and please, that engineers don't make my the face down.
We'll see.
Okay.
No promises, but we'll see.
Okay. Thank you for that.
Thank you so much for doing this interview with me.
Okay. Thank you very much.
No problem.
See you maybe at the end of the year. I like to see also the short time results of that.
Yeah.
Studies.
I'll write a report for you.
Thank you. Thank you.
Right, thank you.
I'm Tegan. Yeah. And what's your major? Oh, I'm a marine bio and environmental chem double major with a sustainability minor. Yes. So let's get started. Today we're going to be talking about wave energy converters, which is a type of renewable energy. And I'm sure you've talked about renewable energy before. What types of renewable energy do you have experience with? Primarily wind turbines or solar panels from sustainability classes, but all of the marine stuff is more floating solar panels or wind turbines. Yeah, other than that, it's just the underwater ones. Yeah, which is what we're going to talk about today. So, as you know, the ocean, it moves a lot. It's got a lot of waves, a lot of currents, stuff like that. So the whole idea behind wave energy converters is to take that energy from the ocean and convert it into usable energy for, the environment, similar to other sustainable energy or renewable energy sources like wind turbines do that with the wind, solar does it with sun, the wave energy converters do it with the waves, which is pretty cool. So one of my favorite types of these wave energy converters are the point absorbers. Have you ever heard of a point absorber? Okay, so I'm going to show you some pictures. These are some point absorbers out in the water. So as you can see, they're kind of in lines with each other. And then this is what the underneath of the point absorber looks like. So you have the top, which is the float. So that goes on the top of the waves and it moves up and down with the waves. Then you have this post that has inside it would have magnets that move with the ocean's currents as well, which creates electricity, and then that goes into the wires and the cables underground that go all the way back to the shore, similar to how other oceanic environments or oceanic turbines and solar panels and all that stuff work. So in here, this is like the inside of the top part. It's got the float, and then this is where like the magnet pieces would be. So does that make sense?
Yeah.
Cool. Do you have any questions about how they're set up?
No.
So I think one important thing to talk about, especially with your marine background, is like how these kinds of things affect, you know, animals and plants and other things that already live in the ocean. So like, what is your experience with that? Like, how would you say like implementing a foreign object into the ocean is like a big problem for ocean life?
Oftentimes it really disrupts a lot of life
Mm-hmm.
because it's a lot of transport and people
Yeah.
coming in and out, especially if there's like tethers going down to the bottom of the ocean.
Mm-hmm.
It means that there's got to be scuba divers. It could also like off-put, depending on where you're implementing them,
Mm-hmm.
the fishing industry.
Mm-hmm.
Fishermen get really upset by a lot of things.
Yeah, they do.
That's what I've learned.
Mm-hmm.
So in that capacity, but it does have like some good things where it could make artificial reefs.
Mm-hmm.
The only thing is that it might disrupt the trophic levels and
Yeah, cause more problems
biodiversity.
than it's worth.
Yeah.
Yeah.
But no one really knows.
Yeah, I think that's the really big thing about this topic in general, is that there's not a lot of research done on the effects of it in the environment, because all of this technology is pretty new.
Oh, no one's looking at point absorbers right now?
I mean, there are people looking at it, and I'm sure there's lots of research happening in this field, but it's all very new. Like, we don't have very many implemented in the world. So, I mean, the other thing about these point absorbers is that they're very low efficiency ratings. So, like, they're only like 30% efficiency. So you're really, even though there's a lot of energy that could be tapped into in the ocean, a lot of it's not being used to its full potential, which is like kind of a problem in this scenario. The other thing is like they're really expensive, which I mean I think is true of a lot of marine construction, but
Yeah. Got a lot of problems over there.
yeah. But yeah, I think they're pretty cool though, and they're interesting implementation. But I think we kind of have to work together as marine and engineer to, you know, better the environment and create these devices that will not only help the environment in general, but not cause further harm to the ocean. Yeah.
Yeah.
Do you have any other thoughts on this topic? Any other questions?
Yeah.
Jim? Yeah.
So you mentioned before that they would be put in lines.
Mm-hmm.
Would those be like spaced out, or would they just line the ocean?
Yeah, so they would be pretty evenly spaced out. They're connected with these cables, like these underground cables. So essentially you'd have like 3 stacks of them, and then they would all run into the same cable that goes to the shore, which is interesting because it makes it difficult to scale. Like once you have some implemented, it's difficult to add more with them to be like a farm like you would expect. So yeah. But that's definitely something that they have to do more research on. But
So another question
Yeah.
is when you like put them into the ocean and there's like that tether point
yes.
in the magnet, how deep down does that go? Like, is it just at the top where all like wind is being generated, where waves are, or is it like also taking into account like the different levels of the ocean in the circulation there?
I think it would depend on the type of float. So like some of them are fully submerged underwater, like completely all the way. But then some of them are like this where they're floating on top. So it really depends on the type. But overall, I think they're partially submerged usually, and then they'll go all the way down to the bottom of the ocean floor. But the magnets are occurring in the middle. Cool. Yeah. So, point absorbers, wave energy conversion, pretty cool.
Very cool.